Okay, so what about if the question is, or if the problem is, given a normal distribution with mean of 8 and standard deviation of 2, find the area to the left of x equals 9, to the right of x equals 10.5, and between x equals 8.5 and x equals 11. If you remember the first example, we have answered a problem in which the values given are the z-scores. In this new problem, the values are given in terms of x. Okay, so how is this different to the problem that we solved in the other video? Okay, now take note, this is very important, that before you can use the z table, that means you have to use z and not x. It is called z table because it is for the z values, right? So if you're given the x values, then you have to convert them first into z. And to convert them into z, always remember that z is x minus mu divided by sigma, or the standard deviation. Okay, now let's start with x, or finding the area to the left of x equals 9. So in the normal distribution, so according to the problem, the mean is 8. The mean is 8, standard deviation is 2. The center in the normal distribution is 8. And 9 is a number to the right of 8. So to find the area to the left of x equals 9, we have to convert the normal distribution into standard normal distribution. And that is to make the 8 equal to 0. So what is 9 in the standard normal distribution? So we can find the corresponding z-score of 9 by using z is equal to x minus mu over the standard deviation. And that is 9 our x minus 8 divided by 2. So this is equal to 1, that's 9 minus 8 over 2. And best to change this into decimals, and that is 0.5. This is the z-score for x equals 9. So let us locate 0.5. 0.5 is a positive number, so we have to use the z table containing the z, or the positive z-scores. 0.5 is, so consider 0.5 as 0.5 and 0.00, because we don't have a second decimal value. So 0.5 is located here, and 0.00 is here. So the area that we need is the area 0.6915. This is the area to the left of a z-score, so we are done with the first question. So the answer, the area to the left of x equals 9 is, as based on the table, it's 0.6915. So let's write that down. 0.6915, or in percent, that's 69.15%. Now let's locate the area to the right of x equals 10.5. To find the area to the right of x equals 10.5, always, okay, what you have to do always is to change the x into a z. Okay, so if x is equal to 10.5, then its z value can be obtained by x minus mu over the standard deviation, sigma. Replace x by 10.5. Mu, according to the problem, is 8, and then divided by the standard deviation is also given, and this is equal to 2. 10.5 minus 8 is 1.5 divided by 2. Then you can use a calculator to find the exact value. This is equal to 0.75. Okay? So again, you break this down into 0.70 and 0.05. You can check that. If you add, that's 0.75. So locate 0.7 on the table. It's a positive number, so 0.07 or 0.7 rather is here, and then 0.05 is here. Trace, follow the row and follow the column, and this is the area to the left of 0.05. So we have, in that area, we will take note 0.7734. So the area for this is 0.7734. But you have to be careful. This is the area to the left of 0.75. And the one that we want to find is the area to the right. So to finally find the area, consider the whole area 1 and then subtract 0.7734. If you will subtract this, you will get 0.2266, and this is the area to the right corresponding to the x value equals 10.5. Okay, so the only thing that is added here as compared to the first problem is, if you are given an x value, you have to change, or you have to find its z-score counterpart before you can use the table. Do not rush using the table if the value is not yet in z-score. Unlike in the first problem, the values given are all z, so we went straight to the z table. And again, to find the counterpart, z-score, you always have to use the formula z is equal to x minus mu over sigma, or the standard deviation. Okay, and then lastly, so this is 0.2266. Area in between, something that we have done in the previous problem. You are still given two numbers, but this time they are written as x. So again, you have to find their z-score counterparts. Okay, so let's take note. The x concerned are 8.5 and 11. So in the normal distribution, or the normal curve, 8 is the mean, and then these are the numbers that we have to consider. So we have to convert this curve into a standard normal curve in which the 8 becomes 0. Okay, so the mean will always become 0, and that is still consistent with z equals x minus mu over sigma, because when x is equal to the mean, that means 8 minus 8, and whatever the standard deviation that you have, this will become 8 minus 8 is 0, 0 over the standard deviation is 0. That is why in the normal curve, or standard normal curve rather, the mean is now changed to 0. So our concern is to change 8.5 into a z and 11 into a z. So we will just repeat the process So by first considering x equals 8.5, the z is equal to the x 8.5 minus the mu, which is 8, divided by the standard deviation, which is equal to 2. This is 0.5 divided by 2. 0.5 divided by 2 is 0.25. Okay, and then for x equals to 11, that is z is equal to 11 minus 8 divided by 2, that is 3 divided by 2, or 1.5. Okay, so the two z-scores that we have to use are 1.5 and 0.25. And let's recall how to find the area in between. To find the area in between, so this is our 1.5, 0 is in the middle, and you have 0.25. The area that we are considering, or that we're looking for, is the area in between these two z-scores. The process that I taught you in the other video is to get, let's change the color, to get the whole area taken from the larger z-score, which is 1.5, and then we have to subtract the area to the left of the smaller z-score, which is 0.25, and the remaining area is the area that we want to find. Okay, so for 1.5, when z is equal to 1.5, we have to go back to the z table. And let's see, that's 1.5, that's 1.0, and 1.5, we can already find that in the leftmost column, and that is 1.5. And then 0, 0, because it's just 1.5, so 0, 0, so the area is 0.9332. So the bigger area is 0.9932. That is taken from the z-score equals 1.5. Now we have to subtract the area to the left of the smaller z-score, the 0.25. We have to take 0.25 as 0.2 and 0.05. Okay, so let's refer to the table again. So 0.2 is here, and then 0.05 is here. You trace to the right, then you trace it down. You have 0.5987. For 0.25 is 0.5987, and then subtract the 2 to get the area in between. So that's 0.9932 minus 0.5987, and that's equal to 0.3945. 0.3945. The area is 0.3945, and again, this will be translated or interpreted as a probability, and you will say 39.45%. Okay, so that's an example when you want to find the area given that the values are still x values. The key is always to change them into z-scores and then use the corresponding table to find the area. Always take note that the tables are showing the area to the left of a z-score. So be careful when you get a copy of a table. Make sure that it contains the area to the left, because there are other versions of tables in which they show the area to the right instead. In our course, we are using a table that shows the area to the left of a z-score. Okay, that's it.